So this is reassessment number 4, and I wanted to find the stretch of a carbon wire, um, and also wanted to find the stretch of each bond in that carbon wire. And so here we started with some dimensions for carbon. This is the top line, and that's like from the periodic table. And also we found a number for Young's modulus on the internet, and it comes into play a little bit later. So the first paragraph is the calculation of the diameter of one carbon atoms, and it's 2.069 times 10 to the negative 10 meters. Okay, so the second paragraph is we're going to find the tension force, and this is based off of having no momentum and a 1 meter carbon wire that's 1 millimeter thick with a 1 kilogram mass attached to it. And anyways, the tension force is 9.81 newtons. Simple enough, makes sense. Now let's see. Afterwards, we need to find like some cross-sectional areas, and then use those cross-sectional areas to figure out how many chains are running across the wire and how many chains are running the length of the wire. And the cross-sectional area of the wire is 1 times -6 meters squared. That's based off a millimeter. And the cross-sectional area of a carbon atom is 4.2 times -20 meters squared. And let's see, the number of chains side by side is 2.3 times e to the 13th, and the number of bonds running the length of the wire is 4.831. Okay. So okay, the next thing we're going to do is, this is when the 150 gigapascals that I found on the internet comes into play, and we set up Young's modulus and we rearrange it to solve for the stretch of the wire, and the stretch of wire is 6.5 e to the negative 5th meters, and the stiffness of the wire can be found by rearranging the formula for the tension that we figured out earlier. And the stiffness of this carbon wire is 1.5 e to the 5 kilograms per second squared. And then we want to find stiffness of each bond, and this is based off of rearranging the stiffness of the interatomic stiffness times the number of chains divided by the number of bonds. And so anyways, the stiffness of each carbon bond is 31.065 kilograms per second squared, and the stretch of each bond is just, the total stretch divided by the number of bonds in the chain, and it's 1.35 to the negative 14th meters. Each little bond, that's how much it stretches. Very small number. Okay, that's all.